Okay, honors, this is our first unit in pre-calculus, Introduction to Functional Analysis, Shifting, Reflecting, and Stretching Graphs of Functions. So you might think, like, why does some of this stuff look familiar? That's because we are looking at some things from our Math 3 or Algebra 2 from last year. However, we are kind of just taking things sort of to the next level and thinking analytically, interpreting and identifying characteristics of functions in this one. In other words, we're just becoming experts, being able to look at a function and being able to go straight to the graph, or looking at a graph and being able to go straight to the function. Okay, we're refining and taking further our skills, improving our lateral thinking. Okay, so I'm just reading off from here. Many functions can be graphed by simply knowing the general shape of basic graphs of functions and understanding what effect adding, subtracting, and negating certain parts of the function have on the graph. Graph each of the functions below in the graphing calculator and then state how the change in the equations for graphs b through I affect graph A. Now you can go ahead and do that. Okay, now you'll notice in our curriculum this year that there'll be a lot of cases where you will not be able to rely on your calculator. Okay, now I would suggest that you try and do that now, or otherwise it'll be a lesson learned hard later. Okay, so anyway, the basic square root function, what does this look like? Okay, now let's take 0. Okay, so when I plug in 0, square root of 0 is just 0, so I'm at the origin. When I plug in 1, square root of 1 is just 1. It's a perfect square. Let's take the next perfect square. It would be 4. So when I plug in 4 here, square root of 4 is 2. So I'm right here. Okay, that's enough points. Go ahead and just graph this way. Now, I can't take a negative, right? Because if I plug in -1, I get the square root of -1, and recall that you're going to get an imaginary value. Okay, we're in the real number line, the real number system. Okay, so we cannot plug in any negatives. We're dealing only with the principal square root. Okay, so no negatives. Now, here's where, again, you can use your calculator, or you can just take simply by plugging in values, something you're going to have to get very used to in this whole year in pre-cal. Okay, so I suggest doing it this way. Pause the video and see if you can finish all the way through box I, okay, and then compare to the video, or just take it one at a time. Okay, so go ahead, pause the video and try the rest on your own before you look at how they work here. So if I plug in 0, okay, if I plug in 0, square root of 0 is 0 plus 2, I get this point there, right? At x is equal to 0, I get positive 2. When I plug in 1, square root of 1 is 1 plus 2, I get 3. So at x is equal to 1, I have 3. Okay. What about 4? When I get square root of 4, I get 2. 2 plus 2, I get 4. So right here. So let's see what happened. Okay, look at these points compared to these points. Instead of being at 0 or the origin, I shifted up 2. Similarly, instead of being at 1 comma 1, I'm at 1 comma 3. My y value changed. Okay, right here I'm at 4 comma 2. Right here I'm at 4 comma 4. Each point, in other words, went up 2. Okay, so this plus 2, okay, compared to the basic function, it allowed me to shift up 2 units. Okay, you can guess at the next one. Okay, you can make an educated guess. Subtract 2 on the outside, so the -2 here is going to shift the basic function downward 2 units, and it does. Okay, when I plug in 0, I'm gonna get -2. If I plug in 1, I get 1 minus 2, -1. When I plug in 4, I'm going to get 2 minus 2, which is 0. Okay, and if you compare this to the original, look at the points. Okay, they shift down 2 units. Okay, this point here shifts down 2 units. Okay, and then finally the origin here shifts down 2 units. Okay, so I'm going to go a little bit faster from here. Shift, whoops, I misspelled shift there in the second one. Shift down 2 units. Jesus Christ, I don't know what's wrong with my spelling. Okay, shift down 2 units. Next one, add 2 on the inside. Okay, so what happens when I plug in some values? So 0, I'm gonna get positive 2. Square root of 2 is not a perfect square. It's like 1 point something, but it just creates a complication for me to try and be accurate here. So let's try to plug in x values that will give me perfect squares. Okay, so let's say I want to get 0. How do I get 0 on the inside? I would have to plug in negative 2. Negative 2 plus 2 is 0, which is 0. So here, when I plug in negative 2, I get 0. Now, let's get the next perfect square. How do I get 1? Okay, to get 1, I will need to plug in negative 1, right? Negative 1 plus 2 would be negative 1. So I would get negative 1 plus 2. I get positive 1. Square root of positive 1 is 1. So that point there. Next one, I want to get 2. I want to get 4, sorry, square root of 4, because that gives me 2. So how do I get 4 on the inside? I have to plug in 2. So right here. If I plug in 2, 2 plus 2 is 4, would be square root of 4. So I'll be there. And I have this graph here. Okay. How does this compare to the original? Now that instead of the value being outside, it's inside the square root, right? Notice that to the original basic square root function here, it looks like I shifted every point to the left 2. Okay, so this one would be shift left 2 units. Pause the video and just compare the the points. Okay, so 0, 0, negative 2, 0, 1, 1, negative 1, 1, 4, 2, 2, 2. In other words, everything got shifted to the left, so you took away 2 from each x. Okay, so let's look at what the next one does. Instead of plus 2 in the inside, here I have minus 2 in the inside. I'm subtracting 2 from the inside. So let's see what that does. Okay, so same way, I want to get 0 here inside first. Okay, how do I get 0? Because I know that's where it's going to start, when my function starts. So when I get 0, to get 0, I have to plug in positive 2. So 2 minus 2 would be 0. So here, okay, x is equal to 2. Let's get 1. How do I get 1 on the inside? I have to plug in 3. 3 minus 2 is 1. There. Okay, the next one is I want to get 4 here. So how do I get 4 here? I have to make this 6. 6 minus 2 is 4. So at x is equal to 6, you're going to get 4, which is 2. Right? 6 minus 2 is 4. Square root of 4 is 2. So that's my graph there. So how does this compare now to the original the basic square root function, right? It looks like everything shifted to the right 2 units. So shift right 2 units. So when it was plus 2 on the inside, you shift left. When it's minus 2 on the inside, you shift right. Okay, now here's f. Multiply the outside by negative 1. I have a negative x here. So let's go ahead. It looks almost similar to the original. Okay, so let's go ahead and plug in some values. If I pick 0, square root of 0 is 0 times negative is still 0. So I'm at the origin. Let's take 1. Square root of 1 is 1, but times is negative makes it negative 1. Okay, so I'm here. Okay. Whoops, no, that's not right. This is incorrect. When I plug in 1, I got negative 1, so it's actually down here. Sorry about that. Next one, 4. When I plug in square root of 4, when I get square root of 4, I have 2. This minus would make it negative. So I am down here. Okay. So that's what it looks like. Notice, how does this look to the original function? Okay. I'm still going to the right. All of these are going to the right. I'm still going to the right in this last one. But instead of going upward, right, towards the positive infinity, right, on the y, I'm going towards the negative, right, of the y's. So this one reflected across the x-axis. And this makes sense, right? If you hold like a mirror here, right, to this original basic function, it's going to look like it's going this way. So on the reflection. So that's what this does. When you have a minus in the front, on the outside, but in the front, okay, it's going to reflect over the x-axis. This is true for all functions, all of them. Okay. Now let's pause here and recall some of you guys might be like, this is familiar, why are we doing this again? Okay, because it should be. Okay, we did this. Recall that the basic function for transforming, okay, at least for square roots here, we had a times the square root of x minus h plus k, right? And recall that if a was greater than 1, we had a vertical stretch. Did I spell this right? No, I did not. Stretch. Okay. If a was less than 1 but greater than 0, okay, we had a horizontal stretch. Whoops, a horizontal, not a horizontal, more on this a bit, on horizontal stretches, okay, but this is actually a shrink, a compression, right? We call this a compression. Wow, I even forgot vertical. It's a vertical stretch, vertical compression, okay? And then if a is negative, you had a reflection across x-axis, okay? And then remember how the h and the k worked, okay? If it was minus h, it's like plugging in a positive here. It doesn't change the sign, right? So if you have minus h, you had a shift to the right, right? Because it stays minus if you plug in a negative. But if you plug in a negative, minus negative is going to turn positive. So if you have a plus h, right, you have a shift to the left because it's a negative value, okay? So those are it. Oh no, wait, one more, right? K. What does k do? K is your vertical shift, okay? So whoops, just realized I'm outside of frame here. So pause the video, see if maybe you can just compare the ones we just grabbed to this. Okay, it should make sense. This here's what we did last year. Okay, but yeah, that's basically what this is. We do take it to something new though on the next page. Okay, so there is more to it, and it was the one that I was starting right here, the horizontal stuff. Okay, there is some horizontal manipulations going on as well. So let's look at the next few ones here. So here, G, it says multiply the outside by 2 and multiply x by -1. So if we just compare the one to what we just wrote here in the bottom, a is greater than 1, so I have a vertical stretch. What does a vertical stretch mean? Remember that a vertical stretch means whatever I plug in for x, whatever this gives me, I multiply everything by 2. Okay, that means I'm going to make it bigger. That's what I mean by a vertical stretch. It makes the y bigger, because whatever I get, I'm going to multiply by 2, making it bigger. Okay, so I have minus x as well here. Okay, this is also the new thing. We didn't really talk about these last year in our Math 3 or Algebra 2. Okay, so when I plug in 0, square root of 0, it becomes 0 here, right? Square root of 0 is just 0 times 2 is still 0. So I'm at the origin. However, when I plug in 1, I'm going to get negative 1, which is imaginary, right? I can't take that, okay? I want to get positive 1. So what can I plug in to get positive 1 here? It would be negative 1. So negative 1 plugged in here, I'm going to get positive 1. But then I multiply by 2. So I get 2. Okay? Notice how this is comparing to the basic function. Okay? Instead of having a point here, it's here. That's what the stretch does. Okay? Now, let's take the next perfect square. I want to get this to be positive 4. So I have to plug in negative 4. Okay? Minus negative 4 becomes positive 4. Because square root of positive 4 is 2. 2 times 2 is 4. So at negative 4, I have positive 4. There. Okay? And again, compare this. Let me see if I could just flip through the pages here. Compare this, and we don't have one to compare exactly to, right? But notice how the function looks taller to the basic square root function. Something else that happened here, okay, is instead of going to the right, and all of these in the first page are going to the right, this one is going to the left, okay? And that's what the negative here did. When you multiply the x by the negative 1, okay, right here, instead you had a reflection across the y-axis. Okay, so that's something that's new. So you have a vertical stretch of, vertical stretch by factor of 2, and then you have a reflection across y-axis. Okay, so that's G. For H, it says multiply the x by negative 1 again and subtract 2 on the inside. Now, a couple things. We need to get, there's two ways to look at what's inside the radical here, okay? We could look at it as taking this and seeing where would my radical start, okay? And where does it start? It is where it would touch the x-axis in a sense, right? And you want it to be, you want the, where does it hit the x-axis? Where your y is 0, right? When all of this is equal to 0, whatever x value you plugged in, that's where it's starting. Okay, so you can look at it as negative x minus 2 is equal to 0, because you want the inside to be 0. So if you solve for x in this case, let's see, you get negative x is equal to positive 2, you get x is equal to negative 2. So when x is equal to negative 2, right here, all of this would be 0. That's where the function starts. Okay, now a couple things. Oh, sorry, here's the other way to look at it. Yeah, minus x minus 2. So you're gonna actually go ahead and think of it as, what happens if I factor out a negative 1? You're gonna get x plus 2. Okay, so this is another way to write it. Okay, so now you can compare it to that transformation note we did on the other page right here at the bottom, and you can see that it's a plus 2, which means you're gonna shift to the left, right? You're gonna shift to the left 2 units, and you have this minus here in the front, so you are taking the whole thing and reflecting across the y-axis. Okay, so from the very beginning, especially with this minus here, you should already have known or noticed that it's going to go to the left. Okay, and now that we've written it this way, we can see that it's going to be shifting to the right. Now if you would have just plugged in values, you would have still gotten the picture as well. Okay, it would have just taken a bit more time. So let's go ahead and see what these are then. Let's plug in, let's see, I want this to be equal to 1, right? So if I want this to be equal to 1, I have to plug in -3. Why? Because if I plug in -3 here, negative becomes +3. 3 minus 2 becomes 1. Square root of 1 is just 1. So I have that point there. Okay, now let's take the next one. I want 4 here, right? So 4 in the inside, so I have to take -6, because it becomes +6 minus 2 is +4, so I get square root of 2. So there. And again, this holds. Okay, it's going to the left again because of the minus here, and I am shifting to the right because it's really shifting to the left because it's really +2. Okay, now let's take this one. It says multiply the x by -1 and add 2 on the inside. Okay, so it's another way to oh sorry, I forgot to write the description here. Right, so reflect over y-axis, and then shift left 2 units. Okay, sorry about that. So for the next one here, I have -x plus 2. Okay, so let's think. Okay, what is this gonna how do I get 0? Okay, so -x plus 2, I need to plug in +2, because it becomes -2 plus 2, that's 0. So I know I start here. Okay, now if I plug in, I want to get 1 now, +1 in some way. Okay, now here's the thing. What happens when I plug in, actually no, I'm overthinking it, right? I could just plug in -1, right? If I plug in +1, I get -1 plus 2, which is +1, so I can just leave it as plugging in 1, right? That's going to give me square root of 1, which is 1 there. Now I want to get 4. Okay, now notice that it's going towards the left side, and this makes sense because I have the negative here in the front. Okay, so it is a reflection across the y-axis again, so let's write that down right now. So reflect over y-axis, and then let's check to see why we're shifting over to the right. Okay, so what was it? Sorry, where was I? Oh yeah, I want to get 4, right? So what do I plug in here to get 4? So I want to make this +2, so I have to plug in -2. Plug in -2, it becomes +2. +2 plus 2 is 4. Square root of 4 is 2. So if I plug in here, right, I would be here. So notice to the original function, I also shifted right 2. Okay, and another way, why is it shift right if this is +2, right? If we're thinking of it, here's my transformation notes, right? If it's +h, that means I would have plugged in a negative, which means I would have to have shifted to the left. But according to this, we're shifting right. According to this one, we're shifting right. Okay, and it's positive. Okay, that's because another way to look at this right here. Okay, so here's the one we have, -x plus 2. You can look at it as, you can also factor out a minus. You'll get +x minus 2. right? If I distribute this negative in, I get the original, what's here, okay? So the minus still has me reflecting over the y-axis, but notice that it's a -2. So now if we look at it compared to this, it's actually this one. So you're shifting to the right, which is right there, okay? Alright, moving on. It says, based on your observations, predict how each of the graphs of the functions below would be different from the graph of f of x is equal to x. State the changes that would be made to the basic graph, then state the domain and range of the function. Okay, so now we're going to the more like mastery level. How fast can we just look at these equations and then state the transformations? And then they also want us to state the domain and range of the function. So let's see. Okay, so for this first one, let's just look at it. Okay, I got a vertical stretch of 2 because there's a 2 in the front. Okay, so I have a vertical stretch of 2. Okay, let's list them. So I'm gonna put 1. Okay, let's see. I also have the minus here, so I know for a fact it's gonna be reflected across y-axis. Okay, I have a positive 1, but remember, okay, it's like looking at it. What happens if you undistribute the negative, right? It would be x minus 1. Okay, so it's actually a shift to the right 1. Shift to the right 1. Okay, so again, it's like looking at this as minus x minus 1. If you distribute the negative in, you get what's in here. Okay, and then finally the last transformation, here's the -3 outside, you're gonna go down 3. So shift down 3. Okay, so taking these transformations here to the basic square root function, right? I would shift to the, like if I was starting at the origin, right, and I am, because let's see, am I starting at the origin? Actually no, I'm not. Okay, but I would take, well yeah, you do start at the origin, right, but then I don't end up at the origin. You shift down 3 to the right 1. Okay, so taking to the parent function, which is at 0, 0, I shift down 3 to the right 1. So that's the point that I am starting at. Okay, reflecting over the y-axis, so I know I'm not going this way, I'm going to have to go this way. Okay, but every single point from there on is going to be stretched by 2. Now here's where you can get just basic characteristics, right? Notice that, let me see, and it's probably better to look at this page here. Notice that most of these functions, the point that's either to the right or to the left, if there is no vertical stretch, it's just the next point over, like to the right 1, up 1. Okay, think slow. To the right 1, up 1, to the right 1, up 1. Okay, well, not necessarily slow, but you get the idea. Down 1, right 1. Okay, if there is no stretch, okay, if there is a stretch, you multiply the vertical, right? It's a vertical stretch. You multiply the vertical movement by 2. So instead of to the left 1, up 1, it's going to be to the left 1, up 2. Okay, so that's a shortcut. Okay, for the last point there, or just continue thinking of what it means, right? This one here, it's a vertical stretch from the original here. So I go up to the right 4, up 2, right? To the right 4, up 2. To the right 4, up 2. Okay, it's a vertical stretch of 2. So instead of going up 2, you're gonna go up 4. Okay, but still to the right or left 4. Okay, so right here I have 1, 2, 3, 4, but instead of up 2, I'm up 4. So I'm going to be right here. Actually, wait, did I mess this up? 1, 2, 3, 4. Yeah, 1, 2, 3, 4. So it's going to be right here. Okay. And again, plug in some values just like we did in the other ones, and you'll see that it holds. Okay. For h of x, actually no, wait, we're not done. It says state the domain and range. Okay. So what x values are being covered here? What are the possible x values for this function? Okay. So reading from left to right, we got all these here, negative infinity, comma, and they go up to 1. 1 is included. Okay. Your range is your y values. Okay. What's the minimum y value? Negative 3, and it is included, and it goes up. Okay, it doesn't look like it continues to go up, but it actually does, and it continue to go this way, this way, this way, this way, and it keep going up, and all y values going up would exist. So it's negative 3 comma infinity. Okay. All right, let's look at this one. So let me see. I have a negative in the front. Okay, so I know I have a reflection across y-axis. I have no negative in front of the x, so it's just x minus 1. So I plugged in a positive 1, so I know I have a shift to the right 1 unit. Whoops, and I forgot unit in this one here. Okay, shift to the right 1 unit, and then the plus 3 will tell me shift up 3 units. Okay, so already we should be able to visualize what this looks like. What does h of x look like? And I start from the origin usually, but instead I'm shifting up 3 units and then to the right 1. So here's where I'm starting. Okay, now I have a reflection over the y-axis, so instead of going this way, I go this way. Notice that there's no stretch, there's no change, and actually, wait, didn't realize. Wait, what's the remount? Oh, okay, I see. There's no minus in there, but it's outside, so it's actually a reflection over the x-axis. I apologize there. It's not y-axis, it's the x-axis. Okay, because the negative is in the front, outside. So that's where I'm starting. Okay, this point's still correct, but instead of going this way, I'm going to be going this way. It's a reflection over the x-axis. Okay, so going this way instead. So I have the general form. There's no vertical stretch or shrink of anything, so I know I'm going to have a point there, right? And then, and you can verify if you plug in 2, right? If I plug in 2, 2 minus 1 is 1, minus 1 plus 3, you get positive 2, so it's right there. Let's take in the next one. I want 4, so I have to plug in 5. 5 minus 1 is 4, which is square root of 4 is 2, minus 2 plus 3, and I get 1. So there. Okay, that's what that one looks like. My domain, what are the x's? From 1 that way, so from domain is from 1 included to infinity. My range, instead of going upwards, is going downwards, right? The highest one I have is 3, but I can start, doesn't look like it, right? But this is going to keep going down forever. Okay, so again, from down upwards, my range, I come from negative infinity all the way up to 3. Okay, and that's that. Alright, so we're working through this. Okay, so let's complete the table below based on the observations that you have seen in the previous examples. Okay, so we took the square root functions and then we studied what the transformations did to them. Okay, now we can generalize. That's what this table here is doing for us. Okay, we're generalizing those transformations. Describe the shifts and or reflections that the graph of f of x undergoes. Y is equal to f of x plus c. Okay, remember that this is outside of the basic function. Okay, look at f of x as the basic function, c is the transformation. Okay, so when it was f of x plus c, these were shift up c units, we'll call it, yeah, c units. When it was f of x minus c, you shift down c units. When the c was inside with the x, remember, and it's plus c, you would shift right, you would shift left. Shift left c units. When you had a minus c, remember it's like plugging in a positive, didn't change the sign, so you would shift right c units. Okay, let's actually pause and let's do this one actually, because I'm not liking the way it's being left out. So if you shift up c units, what does describe what would be done to the x and or y coordinates of the graph. So if you shift up c units, you have x comma y plus c. In this one you have x comma y minus c because you're shifting down. This one you shift left c units, so towards the negative side you're subtracting from x, so x minus c comma y. This time you're shifting to the right, so you have x plus c comma y. Right here your y minus f of x, so the minus is in front of the function, right? So this is where you reflect over x-axis. Okay, and what happens when you reflect over the x-axis? Okay, let me actually bring one up real quick. Actually I'm going to need to bring both of them up. So here's the basic function, right? Take a look at these points, and then here is, actually, yeah, let's take these two. Here is the one with the minus in the front. Okay, so again, the basic function was like this. The one reflected over the x-axis is like this. Notice that the x coordinates of these points doesn't change if they were up here, right? They don't change. Still x is equal to 1, 4, and so on. Okay, what changes is the y coordinate. The y coordinate went from positive, right, to the negative. So right here, oops, right here, when you reflect over the x-axis, okay, your y's become negative. Okay, the next one, what happens when now you're within the function, right? Just like right here we were shifting left and right. What happens where you have that again, but this time you add something, right? Just in other words, combining these, it's taking a combination of these. So right here you would shift, because you have a positive c, you shift left c units, and then the d is shift up d units. Okay, so this would be shift left, so x minus c comma y plus d. The next one just takes the opposite. You have let me see, shift right instead, right c units, and then you shift down d units. So shift right, I got x plus c, and then down would be y minus d. The next one, Jesus, okay, I'm getting tired of this repetition. So shift left, c units, shift down d units, and this is this would be x, whoops, shift left c, so x minus c, comma, y minus d. The next one would be shift right, c units, and then d would be shift up d units. So shift right would be 6 plus x plus c, and then shift up d units, y plus d. For the next one, y is equal to f negative x. Notice that now this is like taking in the function. You change it to a minus x. This is like the reflection over the y-axis that we had. Okay, so this is reflect over y-axis, and just like when you reflect over the x-axis, your y values changed. Okay, look back at your graphs. Whoops, I'm not even in view here, sorry. Just like you would reflect over the x-axis and your y values change, they became negative. When you reflect over the y-axis, your x values change. Okay, so it becomes minus x comma y. You have other particular ones, right? Here we have the absolute value of f of x. Okay, it means you can only output a positive value. Okay, in other words, your y will always be positive. Okay, so reflects any part, when you have y is equal to the absolute value of a function, okay, reflects any part of the graph below the x-axis to above the x-axis, because again, you can only get positive y values. Okay, so I mean, you can just go ahead and write that. Reflects any part of the graph below the x-axis to above the x-axis. You can only get positive values. Okay, so x, and then we'll take absolute value of y, because it's always going to be positive. Finally, the last one, when you have a times f of x, you're going to have vertical stretches. And I apologize, I thought we get to horizontal manipulations in this one, but we don't yet. But we will. Vertical stretches by a factor of a. Okay, so you have x, comma, and then a times y. That's how much bigger it's going to get. Alright, next one says, in Algebra 2, you learn how to graph several other functions. Graph the basic functions mentioned below. So what does the parent function of x squared look like? I'm just going to go ahead and sketch most of these. Right, at 1, you get 1 and it's symmetrical. At 2, you're going to get 4, and again it's symmetrical. So we'll start like that. Here's the parent function for a quadratic. Okay. Basic absolute value function. Recall these. Look like this. Here's the parent function for the absolute value, because again, your y values can only be positive unless there's a negative in the front that's being causing a reflection. That's your absolute value function. What does the cubic function look like? The basic cubic function, recall that this one starts off almost similar to the quadratic, right? Sorry, to the square root. You're gonna have, here's the square root, but recall that for a cubic function you can also have negative roots. For this one it is possible, so it looks something like this. Okay, that's what the basic cube function looks like. The basic cubic root function, sorry, the basic cubic function, x to the third, this one, recall that you take everything to the third power, right? So 1 to the third is 1, 2 to the third would be 8, so it's actually, I don't even have enough space here, it'd be somewhere up here. What do you guys get it? The general picture would be something like this. Okay. The next one, the next 4 says, describe how the graphs of each of the following functions will be different from the basic function. Then graph the given functions. Okay, so this takes that general form that we wrote in the front for radical functions right here, and just recall that the quadratic function, the absolute value function, the cubic root function, the cubic function, they all had the same form, where the h and the k were your left and your horizontal shifts, your vertical shifts, your stretches, and so on. Okay, this first one, it's a quadratic and it's in vertex form. Okay, I can read the vertex straight off this, right? Remember that it was f of x is equal to ax minus h squared plus k. Okay, recall that my vertex is read off h and k. H is minus 2 because when I plug in minus 2 I get positive 2. So I have negative 2 comma negative 3. So my vertex is right there. Okay, now there's no stretch, it's just 1, right? So that's basically it. Let's see, it does say describe how the graphs of each one changes, right? So we already did it, right? We said shift left 2, and then 2 shift down 3 from the origin, right? So that's it. There was no other transformation. So from here, right, you can just plug in some values and you can see what you get. But if you do that, you'll find that your graph will look something like this. So I do encourage you to start getting used to it. Okay, you got to be able to do this quick in your mind, where you plug in values and you start seeing where the coordinate point is, and then you just, sketch the graph based off that. Okay, do not rely on your calculators to be able to do this for you. Okay, next one, I have the absolute value function. Okay, again, it looks like this, except instead, I guess it's handy to rewrite these for you guys. Okay, you have x minus h plus k. This is what it looks like for the absolute value function. So right here, I have a reflection over the x-axis. Okay, so let's write that. So reflect over x-axis. I shift to the left one, and then I shift up 4. So I start from the origin, I shift the left 1, and I went up 4. So I'm right here. But instead of going upwards, I reflect over the x-axis, right? And there's no stretch, so it's just every lattice point there. Whoops. Okay. All right. Next one, I have the cubic root function. I have, let's see, there's no minus there, but I do have this minus here, right? So recall, whoops, let me see, sorry, was that over you? Okay, so I do reflect over y-axis this time. However, okay, before I mess up on the left or the right, notice that this is really negative x minus 2, right? So which means I shift to the right, shift right 2, and then the minus 3 is shift down. Okay, so remember that the cubic root function goes something like this, right? But because I'm reflecting over the y-axis, and it's instead going to go something like this. Okay, so let's just graph where the origin would be, right? The origin's right here, but where would that point be? Okay, well, shift to the right 2. So I'll take it here and then shift down 3. So I have this point here. So now I know that this function is going to look something like this. Okay, so let's just grab 2 points to have some semi-accuracy here. If you know the other points, right, they also shift. It takes the exact same transformation. So instead of being at 1, 1 here, okay, because the cubic root of 1 is 1, okay, you could have it here, but then we shift it down 3, 1, 2, 3, and then to the right 2. So you have this point here. Similarly, you're going to have this point here. Okay, so we know this is going to go something like that. Okay, and then for the up one, for the other one here, I suppose we could have a point here where we could be more accurate, but just trying to determine how tedious would that be. It's actually not very tedious. It would be at -8. So you would shift right 2, you'd be at -6. So 1, 2, 3, 4, 5, 6, and then you would shift. Let me see, at -8, you'd be at -2. But then you'd be +2, so you would shift down 3. So it would be like right here. Okay, that's that one. Now I have the cubic function. So I have a reflection over the x-axis. So reflect over x-axis. 2, I have minus x plus 4. So remember that that's really x minus 4, right? When I distribute that negative in, I'm going to get this. So it's really minus 4. So I shift right 4 units. And then shift up 1. Okay, so shift up 1. Okay, so again, I know what the basic cubic function looks like. Okay, so I know it's here, it passes through the origin. I shift up 1 and then to the right 4. So here's where here's where it's actually going to be passing by. Okay, and I know that 1 cubed is 1, -1 cubed would be -1, so there would have been points here. Now, okay, they'll be here. Again, the transformation applies to every single point of the original one. Okay, after a while you'll start trusting it and you'll see that it checks out. Okay, so we can go ahead and sketch just the rest of it from here. We know it's going to look something like this. Okay, Alright. I believe, let's see, I believe that's it for concept 1. Okay, you can start looking at what goes as part of the homework, and let me know if you guys have any questions.